Hi everyone. Greetings to all viewers of Thrones of Knowledge. I hope you are doing well and that goodness surrounds your days. Today's topic is vast, mysterious, and deeply fascinating. We're going to talk about the multiverse theory. What is this idea? And why do scientists, philosophers, and even storytellers find it so intriguing? The concept of the multiverse suggests that beyond our visible universe, there might exist countless other universes, each with its own laws of physics, its own matter, and maybe even versions of us. This is not just fantasy or science fiction. It arises from real challenges within modern physics. For example, when scientists study the Big Bang and cosmic expansion, mathematical models hint that our universe might only be one bubble among many. Think of soap bubbles floating together. Each bubble has its own thin film, its own space inside. Yet all bubbles exist in the same foam. Our universe could be just one bubble, and the multiverse could be the entire foam. The seeds of this idea go back to quantum mechanics. Quantum theory tells us that particles can exist in multiple states at once. Some interpretations, like the many worlds hypothesis, propose that each possibility actually splits into a new universe. That means every decision, every tiny event, might branch reality into parallel outcomes. One where you chose one path, another where you chose differently. Before we move to our today, I want to say that this channel is user-friendly. No offensive content, no misinformation. We explain things with respect, curiosity, and authenticity. To understand the multiverse, we must go deeper into the science of cosmology. In the 1980s, a theory called cosmic inflation was developed. It explained why our universe looks so uniform on large scales. Inflation says that just after the Big Bang, the universe expanded faster than light, smoothing everything out. But inflation may not stop everywhere. Some areas might keep inflating, while others slow down and form bubble universes. This process is called eternal inflation. Imagine popcorn kernels in hot oil. One kernel pops here, another pops there, but the oil is still bubbling. Each popped kernel is like a new universe with its own space and time. Our universe might be just one kernel among countless others. Each bubble could have different laws of physics. Maybe in one universe, gravity is stronger. In another, atoms never form. And in some rare ones, life appears. This idea is controversial. Not all scientists agree, because it is difficult to test directly. But mathematically, it arises naturally from our best models. Another path to the multiverse comes from string theory. String theory suggests that tiny vibrating strings make up all particles. The theory allows an enormous number of possible solutions, each corresponding to a different kind of universe. Physicists call this the string landscape. It could mean that the multiverse contains 10 to the power of 500 universes. That is a number so large it is almost impossible to imagine. Whether through inflation or string theory, the multiverse emerges as a serious possibility. It challenges us to think bigger, beyond the boundaries of the single universe we can see. The multiverse is not just a topic for scientists. It has also inspired philosophy and imagination for centuries. Ancient cultures sometimes spoke of many worlds. In Greek philosophy, Democritus and Epicurus suggested that countless worlds could exist, each born from infinite atoms. In Hindu cosmology, there are cycles of universes created and destroyed endlessly. These are not scientific models, but they show that human beings have long wondered about the possibility of more than one reality. In modern times, quantum mechanics has made this idea feel closer than ever. The many worlds interpretation suggests that every quantum decision creates a branching timeline. If true, it means there are infinite versions of you, one where you chose to watch this video today, another where you did not, one where your life turned left, another where it turned right. Even though it sounds strange, this interpretation is respected by serious scientists. It is not proven, but it is consistent with the mathematics of quantum theory. The multiverse also appears in popular culture. Comics, films, and television series use the idea to tell stories of alternate realities. These are creative interpretations, but they help people imagine what the science is hinting at. Of course, there are strong criticisms too. Some physicists argue that the multiverse cannot be tested and therefore is not a scientific theory. They say it belongs more to philosophy than to physics. Others reply that indirect evidence may exist. For example, if two bubble universes collided long ago, the scars might be visible in the cosmic microwave background. Some studies have looked for this, but results remain uncertain. So the multiverse theory is not a settled truth. It is a frontier of thought where physics, philosophy, and imagination meet. The most important thing to remember about the multiverse theory is that it is still evolving. It is not a confirmed fact, but a framework to explore mysteries our universe leaves unanswered. Why are the laws of physics so perfectly tuned for life to exist? Why did the Big Bang produce a universe with such balance? One possible answer is the anthropic principle. If countless universes exist, each with different rules, then we naturally find ourselves in the one where life is possible. It is not luck, but selection. This does not mean other universes must exist, but it provides a way to think about fine-tuning. Another frontier is advanced simulations. Some scientists suggest that if universes can branch endlessly, then perhaps reality itself might be a kind of coded structure. This is not proof of the multiverse, but another line of thought about the deeper nature of existence, whether true or not. The multiverse theory expands our imagination. It makes us realize that our universe may not be the only story. And in that vastness, we learn humility. All the information we provide comes from verified historical sources, including books, records, and archaeology. Sources consulted include Brian Greene, The Hidden, Reality, Parallel Universes and the Deep Laws of the Cosmos, 2011. Max Tegmark, Our Mathematical Universe, 2014. Stephen Hawking and Leonard Mlodinov, The Grand Design, 2010. Peer-reviewed articles from Physical Review Letters and Journal of Cosmology and Astroparticle Physics. NASA and CERN educational resources on cosmology and inflation. If you found this explanation valuable, please like, share, and subscribe to our channel, Thrones of Knowledge. And don't forget to press the bell icon so you get notified on time. Tell us in the comments what topic you want next to make this journey an even better experience for all of us.